Good morning, madam. Myself, Paul Reddy, studying in SRIT Engineering College in CSM branch. Now, I am going to explain about the construction and principle of and operations of DC motors. Let us see what is that. Introduction. Introduction to DC motors. A DC motor is an electromechanical energy conversion device which converts electrical energy input into the mechanical energy output. It works on the principle of Lorentz law, which states that the current carries conductor placed in a magnetic and electric field orientation and force. That force is the Lorentz force. The operation of the DC motors is based on the principle that when a current carrying conductor is placed in a magnetic field, a mechanical force acts on the conductor. The magnitude of the force is given by F is equal to B. Construction of a DC motor. There are too many parts of the DC motors: armature and starter. The rotating part is the armature and the starter is the stationary part. The armature coil is connected to the DC supply. The armature coil consists of commutators and brushes. The commutator converts the AC induces in the armature into DC, and brushes transfer the current from rotating part of the motor to the stationary external load. The armature placed between the north and south pole of the permanent or electromagnet. Construction part of the DC motor. A DC motor consists of six many parts, which are as the following: yoke. The outer name of the DC motor is the hollow cylinder made up of cast steel or rolled steel is known as yoke. The yoke serves following two purposes. It supports the field pole core and act as a protective core to the machine. It provides a part of the magnetic flux providing by the field winding. Magnetic field system. The magnetic field system is a DC motor in the stationary part of a machine. It provides the main magnetic flux in the motor. It consists of an even number of pole cores bolted to the yoke and field winding wound around the pole coil core. The field system of DC motor has silent poles, that is, poles project inwards, and each pole core has a pole shoe having a curved surface. Commutator. It is the most important part of DC motor. It converts direct current into alternating current. It is a wedge-shaped copper segment insulated from each other and form shift by mica sheet. And armature core. The armature core of a DC motor is mounted on the shaft and rotates between the field poles. It has slotted on its outer surface, and the armature conductors are put in these slots. The armature core is made up of soft steel laminations whereas insulated from each other and tightly clamped together. Armature winding. The insulated conductors are put into the slot of the armature core. The conductors are suitably connected. This connected armature of conductors is known as armature winding. There are two types of armature windings are used: wave winding and lap winding. Brushes. The brushes are mounted on the commutators and are used to inject the current from the DC source into the armature winding. The brushes of the DC motor are made with graphite and carbon structures. These brushes conduct electric current from the external circuit to the rotating commutators. The pressure extended by the brushes on the commutators and maintained at constant value by means of springs. The current flow from the external DC source to the armature through the Fleming's left hand rule. If we stretch the first finger, second finger, and thumb of our left hand to be perpendicular to each other, and first finger represents the direction of the magnetic field, second finger represents the direction of the current, then the thumb represents the direction of the force experienced by the current carrying conductor. Here we can see the above picture. We can see the current carrying direction by our fingers. This representation is Fleming's left hand rule. Working of DC motor. When the DC motor field coil is ingrained, a magnetic field is created in the air gap. The magnetic field that is created is in the direction of the armature. The magnetic field enters the armature from the left side of the north pole of the field coil and exits from the south pole of the side. The conductors located on the other poles get subjected to a force of same intensity in the opposite direction. These two forces created a torque that leads to the motor armature to rotate. If the direction of the current is reversed, the direction of the rotation also reverses. When magnetic field and electric field insert, they produce a mechanical force and tends to rotate an armature. Applications of DC motors. DC motors are used in toys, small tools, electric vehicle, and elevators and steel rolling machines. Thank you for giving this wonderful opportunity.